consecutive ones. So for this example, for this question, we are giving a positive integer n. So for example, n equal to 5. And we're going to return the number of integers in the range 0 to n whose binary representations do not contain consecutive ones. Yeah, so for example, from 0 to 5, this is the binary representation, and only for 3, there's consecutive ones, so we're going to exclude this one. So in total, it's going to be 5. Yeah, it's going to have 5 numbers, 0, 1, 2, 4, and 5. So we're going to return 5. And basically, for such kind of question, we're going to check the countries, because n is 10 to the power of 9. Basically, this is going to be a DP problem. We're going to use the digit DP to solve the problem. So the idea is that we're going to check the binary numbers instead of the digit numbers. So first of all, we're going to turn this number into a binary number, and then we're going to directly use the digit DP template to solve the problem. Yeah. So first of all, you need to know, normally for solving such kind of problem, you have to use a template. And this template is called digit DP template. Normally, we're going to define some variables. So first of all, let me just turn this integer into a string of a binary string. Yeah, because we are just checking the binary numbers instead of the digit numbers. So we can use a bin with this n, and yeah, we can just split the first two digits, first two characters, because that is nothing to do with our binary string. Yeah, we just take out the first two characters. Now we have our string, and we can just define the function. So I'm going to call a DFS function with cas. Here I'm going to use f. So the first one is going to always be the same. But for the second, this I is the length, the index of the string. And for the second one, I'm going to use a variable pre. This means, yeah, let me just maybe this one is better. Is 1. It means the previous digit is 1. This is very important because I use it to detect if there are two ones consecutive. So for example, this is a 1. If the previous state is 1, this means this is an invalid case. Definitely, I will exclude it. So this is the meaning of is 1. And its limit, this is just as always, and its none. This is as always. Yeah. So for the template, normally this one may be different. Sometimes it can be a mask, sometimes it can be a counter, sometimes it can be total. It always depends on what we are requiring from the problem. Yeah. So for this one, because we're gonna check if it is a consecutive one, so we're gonna exclude it. This is why I'm gonna use is1 to check. If the previous digit is 1, definitely the current digit is 1, I'm gonna exclude such cases. Yeah, now I'm going to continue writing the template. If I equal to length of the string, I'm going to return an integer of the its num. Now I'm going to prepare the result. It's going to be starting from 0, and if not, it's num. So I'm going to reset the result. It's going to be equal to f with the next character I plus 1, next digit, and is 1 going to be the same. Now this is limit. I'm gonna set it to false. Yeah, because definitely I didn't choose any digit yet. So this one gonna be the false as well. It's num. Yeah. Now I'm gonna prepare a low and high. Low gonna equal to 0 if it's num. This means for the first digit, for the previous digit, if it is a number, definitely after that I can choose the low as 0. Otherwise, it's gonna be 1 instead of 9. Because currently it is a binary number instead of a digit number. So this is why it is 1 instead of 9. Yeah. High is going to be the same. It's going to be integer of si. If let me think about for low it is 1. Yeah, for high, let me check. If its limit, else it's going to be 1. Yeah, for high it will also going to be 1 because it is a binary number. For the low, we're going to start from 0 if this is a number. Otherwise, we're going to start from 1. And for the highest digit is going to be 1. Sometimes it's going to be 0. It always depends on this binary number. So if its limit, we're going to set it integer of si. Otherwise, we're going to set it as 1. We cannot set it as 9 because it is a binary number. Now we can continue the template. For d digit in low to high plus 1. And if this d equal to 1, and the pre here it is 1. If is 1 is true. If d equal to 1 and is 1, the previous digit is 1. It means 2 consecutive ones. We're gonna continue. Otherwise, we're gonna update the result. Gonna plus equal to f I plus 1, and here it determined on this digit d equal to 1 or not. If it is equal to 1, it is true. Otherwise, it's gonna be false. And its limit gonna be let me think about it. Because we're gonna choose this digit, so the its limit is dependent on its limit and this d, if it is equal to the height or not. And the last one is num. We're gonna set it to true because we choose a digit. Finally, we're gonna return the result. Now, as you can see, the function has already been finished, and we just need to return. The I gonna be starting from 0, is 1 from the beginning, and we're gonna set it to false as our definition. Its limit gonna be true, and its num gonna be false. Yeah, this is just a template problem. We just need to use the digit.dp template to solve the problem. The only difference is this variable. It may be different because this is 1 is to check the previous digit if it is 1 or not. So otherwise, it's gonna always be the same. We're gonna use its limit is number to check. Now let me just run it to check if it works. Oh, it didn't. Yeah, as you can see, if n equal to 5, we're gonna return a 4. If n equal to 1, we return a 1. If n equal to 2, we return 2. Yeah, there is something about the template. We have to be careful about it. For our template, we're gonna always check the numbers from 1 to 5 instead from 0 to 5. But for this problem, we need to include this 0 because 0 is also a valid case. This is why we have to plus 1 to the end. Yeah, it is just because our template. If we were to use the such kind of coding, 0 is not always included. It always starts from 1. Yeah, because we're gonna prepare some empty cases, which means the number is not chosen. So this means we can never get a digit of 0. We can never get this number, but we can only get 1. This is our some constraints of the template, but we have to be careful about it. This is why we have 2 plus 1. Yeah, because the template is just starting from 1, and here we are starting from 0. We have 2 plus 1. If we're going to include 0, definitely we need 2 plus 1. Now let me just run it. Now, as you can see, it works, and let me just submit it. As you can see, it works, and it's pretty fast. And the time complexity is dependent on this I. Yeah, and this I is just a number. It is 10. Yeah, and also for this d, it is just 2 because the low to high is just 2, 0, 1, 0, 1, and this is 0, 1. This is also 0, 1, 0, 1. Actually, the time complexity is just like 10 times 2 to the power of 4. Yeah, basically it's around 100. I think that's all about it. Thanks for watching. See you next time.